Today we are talking about approximating irrational numbers. Before we can actually start to estimate or approximate them, though, we're going to do a little bit of review. So an exponent tells you how many times to multiply a number by itself. So any number to the first power is always going to equal itself. Basically, you're writing that number one time. Any number to the zero power, though, is going to equal 1. So my example is 14 to the zero power equals 1. There is a long, drawn-out explanation for this. Ultimately, it is a rule that you're just going to have to remember. Basically, the short version of this rule is that when you're putting something to a power of itself, you are still multiplying it by 1 and then writing that number however many times it tells you. So since I would write, for this problem, I would write the 1 one time and multiply by 14 0 times. That means my answer is still just 1. That's the shortened version of those rules. But again, it's just something you're going to have to memorize. Some other examples of finding square roots is 8 squared is the same thing as 8 times 8, which gives you 64. What's really important to notice here is that a negative 8 squared is the exact same answer because negative 8 times negative 8 is still a positive 64. If you were to use some of your tricks, like there's 2 negatives there, that's an even amount of negatives, it's going to give you a positive answer. Or if you use your good thing, bad thing trick, you could say a bad thing happens to a bad person, therefore you are happy, or it's a positive answer. So we're going to practice finding a couple square roots. 3 to the 4th power. Again, I could always write 1 times whatever it is, but I don't really need that step. Instead, that 3 to the 4th power tells me I'm going to write the 3 down 4 times. When you're going to multiply these out, I would take them 2 at a time. 3 times 3 is 9. 3 times 3 is 9. And now you can multiply those two numbers together. 9 times 9 is 81. Therefore, 3 to the 4th power gives you 81. In the second example there, I have negative 5 to the 3rd power. So that means I'm writing negative 5 3 times. I'm going to take this 2 at a time. Negative 5 times negative 5. Well, 5 times 5 is 25. And if I use one of my tricks, bad thing, bad person, it's going to give you a positive 25. I still have to multiply by that negative 5 to the right there. 25 times 5 is 125. And a good thing happens to a bad person, so it's a negative 125 for that answer. 7 to the 1st power. That means I'm going to write the 7 down 1 time. And that's it. There's no multiplication to do. 7 to the 1st power equals 7. And again, this is one of those rules that I said you're just going to have to memorize. 15 to the 0 power means I'm not going to write 15 at all, but what is still there is the whole number 1. So 15 to the 0 power equals 1. The other thing we have to review is square roots. So a square root is a number that you can that is multiplied by itself to equal or get the number under the radical. That kind of like check mark, division sign looking thing is called a radical. A square root can be either positive or negative, and the example below shows that. So the square root of 9 could be 3 or negative 3. Because positive 3 times positive 3 equals 9. And negative 3 times negative 3 equals 9. So the square root of 9 is either 3 or negative 3. So when we're finding square roots of these numbers below, again, I'm trying to think of numbers that when I multiply by itself will give me the number under the radical. So when I ask for the square root of 25, I'm trying to think of what number times itself equals 25. Well, 5 times 5 equals 25, and so does negative 5. Both of those are my answer. The other way you will see that, and I'll show you in the second problem there, when you can have a positive or a negative, there's a symbol that you'll sometimes see in front. So when I'm trying to find the square root of 36, the number that multiplies by itself to get that is 6 times 6. It could be positive or it could be negative. That's the symbol in front of the 6 that you will sometimes see. It means positive or negative 6. Both answers are okay. This negative square root of 100. Well, I'm trying to think of what number multiplied by itself gives me 100, and I know that 10 times 10 gives me 100. But instead of it being positive or negative, that symbol out front tells me it needs to be a negative 10. And for the root of 625, this one's a little bit tougher. I would think of some other numbers you know. You know 10 times 10 gives you 100, so it's got to be bigger than 10. If you were to do another easy one to solve, you could maybe try 20 times 20. What you would find is that gives you 400. 30 times 30 gives you 900. So it's got to be between 20 and 30. And what you would find after a couple guess and check is that 25 times 25 gives you 625. And this one could be positive or negative. Reviewing a couple details about irrational numbers. An irrational number cannot be written as a fraction. Not because it's not allowed to be, but because it's actually impossible. In order to be written as a fraction, it needs to be a decimal that stops or has a pattern. And irrational numbers never repeat and never terminate. So they don't have a pattern and they never end. One of the common examples we used was pi. There are several other examples over there. A lot of the time, you're going to see things with a square root above them. So if you flip to the next page, we're actually going to practice approximating these a little bit. So again, it says at the top in bold, we can use square roots and exponent to help us approximate irrational numbers. Approximating means we can get as close as we can to representing that irrational number, but they're never going to be exact because in reality, those decimals continue on and on and on without stopping, without a pattern. So some common ones, like I said, pi, we use 3.14. That is not an exact representation. It's rounded, or it's an estimate, or it's an approximation. Square root of 2, a common one, is 1.41. So in this number line that you see, I want to know, do we know exactly where square root of 42 would go on the number line? At this point, we have no idea where it would be because I don't know the square root of 42. And it's certainly not going to come out to a whole number. So in order to figure out where we're going to place it, we first need to think about what square roots we can place that we know on that number line. So starting all the way over at the 12, just to begin there. 12 times 12 is 144. So above 12, I'm going to write root 144 because I know the square root of 124 or 144 is 12. That's why it belongs on that number. Above 11, I would do the math problem 11 times 11 and I would get root 121. So that's what goes above 11. 10 times 10 is 100, so root 100 goes above there. 9 times 9 is 81, root 81 goes on the top. 8 times 8 is 64, so root 64 goes on the top. 7 times 7 is 49, so root 49 goes on the top. 6 times 6 is 36. 5 times 5 is 25. 4 times 4 is 16. 3 times 3 is 9. 2 times 2 is 4. 1 times 1 is 1. And 0 times 0 is 0. These square roots, all the way from 0 up to 144, the square roots of those numbers you should have memorized. If you don't have memorized yet, you need to get them memorized going forward. As I look at this number line, it can help me figure out where the square root of 42 is going to go. I know that square root of 42, or that number 42, is between the number 36 and 49. That means I could place it between the whole numbers 6 and 7. The reason for that is root 42 is between those square roots above 6 and 7. It's between root 36, that's our whole number 6, and root 49, that's our whole number 7. So I know it's going to be somewhere between those. I don't know exactly where, but I know it's going to be somewhere between them. So when I go to approximate these to the nearest tenth, I'm going to use that number line at the top to help me. So to find root 7 in that first example, I'm going to look at my number line and I'm going to look at the square root part of the number line, and I'm going to figure out what numbers it's between. 7 is between 4 and 9. So as far as the whole numbers it's going to be between 2 and 3. Again, the reason for that is it's between root 4 and root 9. 7's right in the middle of 4 and 9. So my square root must be in the middle of 2 and 3. Now to figure out the approximation to the nearest tenth, I need to do some guess and check. That's really what this is going to become. 7 is 3 away from 4 and 2 away from 9. So it's pretty close to being in the middle. So the first thing I might try is 2.5 times 2.5. You would work that all out, do all your multiplication, and you would end up getting 6.25. Now that is pretty close, but there's a chance that we can get closer. The whole goal of this is to get as close as we can without going over. So the next number I might try is 2.7. You might have tried 2.6, and that's fine also. This is all guess and check. So you would work out 2.7 times 2.7, do all your work, and you would end up getting 7.29. That's too much. So between 2.5 and 2.7, my last guess that I can make is 2.6. 2.6 times 2.6 is the next number. You're going to work it all out, show all your math, and you would get 6.76. That is as close as we can get to 7 without going over, and I'm only going to the 10th place. If I wanted to go to the 100th or 1000th place, we could get a lot closer, but it would also take a lot more work. So when I'm trying to figure out the square root of 7, I can say it's approximately or about, and I'm going to use a wavy equal sign. That wavy equal sign means about. It's not exact. It's about 2.6. We're going to do the same process with the next one, root 89. You're going to look at your number line. You're going to look at the square root part. You're going to figure out where 89 is going to go or what two numbers it's going to be between. It's going to be between the 81 and the 100, which means it's going to be between your whole numbers, 9 and 10. And again, our reasoning for that is it's between root 81 and root 100. So when I go to work these out, I know it's between 9 and 10. 89 is a little bit closer to 81 than it is 100. So when I'm trying to do my guess and check, that means I want to be a little closer to the 9. So I'm probably not going to guess anything bigger than 9.5. That'll be the biggest I go. So the first thing you might guess, and it's totally up to you, I might guess something different than you. The first thing I might guess is 9.2. If I were to work that all out, 9.2 times 9.2, I would get 84.64. At this point, I'm still actually pretty far away from hitting that 89. So I'm going to jump up a couple. I'm going to try 9.5 next. 9.5 times 9.5, if you did all your work, showed it all, worked it all out, you would get 90.25. That is extremely close to square root 89, but it is over. So I'm going to back it off a little bit, go a little bit smaller, and I'm going to try 9.4. If this is still too big, I'll try 9.3, but it might work. So 9.4 times 9.4, if you were to work all this math out, you would get 88.36. That is as close as we can get going to the 10th place without going over. So the approximate square root, which means I'm using that wavy equal sign, of 89 is 9.4. Some people like to put that 88.36 there as the answer. That's not your answer. I want to know what we multiplied to get close to it, and I multiplied 9.4 times itself. So that's the approximate square root. Finally, I've got square root of 105. If I look at my number line, I would notice that it's between root 100 and root 121, which means it's between 10 and 11. As far as which side it's closest to, 105 is much closer to the 100. So I'm definitely guessing things below 10.5. I probably won't even go up that high. The first thing I'm going to guess is 10.2. Again, your guess might have been different than mine, and that's okay. All of this is just guess and check. 10.2 times 10.2, if you did all of this math, you would get 104.04. That is extremely close. It is still just under. You can never just assume that you got it right. So just to make sure that I cannot get any closer without going over, I am going to try 10.3 times 10.3. I might go over, and if I do, I already know my answer is 10.2, but I also might get closer this way. If you work out 10.3 times 10.3, you would get 106.09. That does go over. So that means the closest I can get in the 10th place, or the approximate square root of 105, is about, wave equal sign, 10.2. Make sure you check these notes with your teacher and ask any questions if you have them.